And we're back at it again. So this is going to be day 2 of reviewing via the bookwork, and then remember the next video will be looking at some AP extended response questions so that we can kind of get in the feel for what those are going to start looking like. So instead of just sitting here and talking a whole bunch, why don't we go ahead and jump right back in. This one says, based on past experience, a bank believes that 7% of people who receive loans will not make payments on time. The bank has recently approved 200 loans. So what have they just given us here? They've essentially told us that P is 0.07 and they've told us that N is 200, all right? So looking at A, it says, what are the mean and standard deviation of the proportion of clients in this group who may not make timely payments? So if I am looking at this in a real life situation, 200 people approving for loans, we're going to go ahead and say 7% of them is the expected mean. So what would the mean and standard deviation be? We know that the mean of this sampling distribution, all right, would probably just be, well, that should be a line, should just be our 0.07. And the standard deviation of our sampling distribution would follow our formula of the whole square root of square root of p times q divided by n. So in this case, we know p is 0.07. We know that q is 0.93 by just doing 100 minus 7. And that's going to be divided by our n, which is 200. So if we go ahead and plug that into the calculator, we're going to put that same thing in, 0.07 times 0.93 divided by 200. Take the square root of that answer, and you get 0.018,042. All right. So that would be our mean and standard deviation for this question. Part B says, what assumptions underline your model and are the conditions met? Explain. Now remember, there are multiple conditions when we're dealing with proportion. Those conditions are this. A, they need to be randomized. Now, is this random? It says that they are going to be approving 200 loans recently. Now, is that random? Maybe, maybe not. It's not like they're choosing anyone. They're literally just opening a time period and saying they're taking 200. But it is possible that this is a specific type of time of year where more people apply for loans that are better or worse than usual. So the randomization one would be kind of sketchy, all right? But the next one being the 10% condition, 200 loans is going to be well below 10% of all possible loans out there because you're talking millions and millions of loans. So that's not going to be an issue. 10% condition is going to be met. The next one's going to be our sample size condition, and the sample size condition is saying, is this going to be a big enough sample size for us? All right. This is, remember, a subjective one again, so we're kind of just saying, hey, is 200 a large enough number? In this case, yeah, it doesn't seem super small. It doesn't seem outrageously big and breaking the other conditions, so 200 would be reasonable. The last bit is the success-fail condition. In this case, we have to be more worried about the success, so it's only 7% of those fall into that. So for B, the success-fail condition, we would do the 0.07 times 200, all right? And 0.07 times 200 actually gives us 14, which is larger than 10. So it does pass the success-fail condition, all right? So out of these, yes, the success-fail is met. We believe the other two are met, the 10% and the large enough sample. The only one that would be a little iffy is we're not so sure on the randomization, all right? And you could just say that, like it could be met, it could not be met. We're not certain on the randomization condition. Part C says, what's the probability that 10% of these clients will not make timely payments? All right. So 10% of these clients will not make timely payments. So this is actually now going to turn into our normal CDF type question in the calculator. So we go to menu, Remember, we go to 5, then 5 again, and in this case, we are using normal CDF. Now, in terms of lower bound, upper bound, in this case, the question said over 10%. Now, remember, the average we were expecting is 7%. So when it's saying 10 or over, we're looking at the right-hand side of our normal curve. We're trying to see if it is going to be 10% or anything bigger than that. So the smallest we would have is actually the 10%. And then we're saying it could be anything above that. Now, obviously, it can't go past 100%. So we could just put 1 in this case for being 100%, or you could do the 999 rule if that always makes you feel better. Either way, you're going to get the correct answer in this case, right? So what would we put in as the mean? For this question, we said our mean was the 0.07. And remember, we're not using the standard deviation of the sample or anything. We went through and found the standard deviation of our sampling distribution, and that was 0.018042. So once we plug this in, we're now looking at 10% and higher. So anyone over 10%, so what's the probability that over 10% of them will not pay the loan back? And then we plugged in the mean and the standard deviation of our sampling distribution, and we go ahead and hit enter, and we get 0.048178. All right. Now, if you're wondering, but we didn't use the sample size of 200 at all in that question. Actually, we did. All right. We used the 200 when we found our standard deviation. So even though you don't see the 200 when we plugged in the calculator, we used that number when we put in our standard deviation. All right. So final answer to that last question there should be 0.048178. In other words, there's about a 5% chance that 10% or more of the people would not make their payments for their loans. All right, so that would be final answer there. All right, so this last question that we're going to be covering out of the book here is an awesome question because it gives us a chance to review a bunch of content and kind of connect it to what we're working with now. So if we're looking at extended response questions for the AP test, this would start the idea of the whole like one question can cover multiple parts of what we've done so far this year. Now, I expect that the extended response questions we'll see will be extremely longer than this, but this could be like maybe an A and B question out of like a B, C, D, E, F type question. So let's see what this is saying. It's saying assume that the duration of human pregnancies can be described by a normal model with a mean of 266 days and a standard deviation of 16 days. So it's saying that the model is already normal. So our model is already normal, all right? And it wants to know what percent of pregnancies should last between 270 and 280 days. All right. Now, here's the deal. This first question, what percent of pregnancies should last between 270 and 280 days? This has said nothing about taking samples. So this question A, and in fact B is going to be along the same lines, it mentions nothing about samples. So this is not a sampling distribution question. This is actually going back to the original normal curve questions we had, where it talks about the percent chance that individuals will fall above, below, or in between a certain range. So we still will use our calculators for this, but in this case, we're actually sticking with the original information that they gave us, that the mean is 266 and the standard deviation is 16, all right? So if we want to fill that in, we know that the mean in this case is going to be 266 and the standard deviation is 16. We know nothing about a sampling distribution yet, and it hasn't asked us anything about a sampling distribution yet. So we're going to jump straight into just doing that question, all right? And it says here, what's the percentage of pregnancies that should last between 270 and 280? So we're going to jump over to our calculators, and we're going to hit menu. We're still going to go to our normal distribution, even though we're not dealing with the same thing we had. We're not dealing with the sampling distribution in this case, but we're still dealing with a normal curve because it told us that it was going to be normal, all right? So remember, when we're looking at this, we have a mean of 266 and a standard deviation of 16. So So I can plug that right in, 266 and 16. But what about our lower bound and upper bound? Well, this specific question said from 270 to 280. So that means that our lower bound is going to be 270 and our upper bound is going to be 280, all right? So we go ahead and hit OK and find out that our answer in this case is going to be 21.0507 if we're talking about a percent. Or you could just leave it as the 0.210507. All right. So for A, again, it was 21%, 21.05%, or if you're leaving it as a decimal, well, no, you should put it as a percent because it says what percentage of pregnancy should last. So we would go with the 21.05%. Okay. Next question says, at least how many days should the longest 25% of all pregnancies last? This is our old school backwards question. It's saying how many days should it take for it to be in the longest 25 of all pregnancies? So in other words, we want to know where is the cutoff in terms of days for our longest 25%. So we want to know the top 25%. Again, we have not mentioned anything about sampling distribution. So we are not dealing with our new numbers at all. We are dealing with the original numbers. And because we are given the percent here and we want to know the X value, that means that we are actually doing a menu 5 inverse norm. It is an inverse norm question because, again, it gave us the percent and we want to find the number that would be the cutoff. All right. So area, remember the area is always calculated from the left-hand side over. So even though we're looking at the top 25%, that's the top side. So how much would be below that? Well, if you're looking at 100%, the top 25 means how much is left below that marker? Well, 100 minus 25 gives us 75. So this would be 0.75. In terms of our mean and our standard deviation, we are still dealing with the 266 and the 16. So I'm going to go ahead and plug in and 16. And when I hit OK, this is going to be our answer to B, the 276.792. All right. So again, if I'm looking at this question, at least how many days should the longest 25% of pregnancies last? Well, the cutoff to be in the top 25% would be 276.792 days. So that means that to be in the top 25, you always want to round above it because 276 would be high enough. So we would say you would have to have at least 277 days. If you were pregnant for 277 days or more, you would be in the longest 25% of all pregnancies. All right. So again, that was an inverse norm question, and the answer was 277 days. All right. C, suppose a certain person is currently providing prenatal care to 60 pregnant women. Let Y bar represent the mean length of their pregnancy. According to the central limit theorem, what's the distribution of this sample mean Y bar? Specify the model mean and standard deviation. So this is finally where they're saying, check it out. We have a sample of 60 and we want to know what the distribution would be of a sample like this. All right. So that means that they have finally switched over to a sampling distribution question where n is going to be equal to 60. All right. Now, what does that mean for us? It means that for these questions, if we are working through these, we will be using our new mean and our new standard deviation. And that's actually what this is asking for specifically. It says specify the model. Now, normally would be like, okay, do we meet all of our conditions as we go? Is our sample size big enough? Is everything is good? Are we nearly normal? In this case, we don't have to worry as much about the sample size because our original data was normal. So we know that the sampling distribution is going to be normal as well. So we don't have to freak out as much. Again, this is not a proportion question, we're actually dealing with quantitative data because they gave us a mean and standard deviation from the very beginning. So we're not dealing with the proportions, we are dealing with the mean and standard deviation questions we did later on in the chapter, all right? So what would our new mean be? Remember, the new mean of a sampling distribution is just whatever the original mean was. So we are still sitting at that 266. Now, on the other hand, the standard deviation is a little different. And in this case, remember, I put it down here for us in case you forgot. The standard deviation for a question like this is whatever the original standard deviation was divided by the square root of the sample size. So in this case, our original standard deviation was 16, and we're going to divide that by the square root of our sample size, which was 60. If we plug that into the calculator, then let's see, we can just do this one together. It's going to end up being, we said 16 divided by the square root of 60. And it tells us that that standard deviation is 2.06559. So we just found out that this guy is actually just going to be 2.06559. All right. So there's our new standard deviation. Okay. So now what about the model? It says specify the model, the mean, and standard deviation. Well, if the original model was normal and now we're dealing with the sampling distribution, we would also expect this one to be normal. All right. And that's by the central limit theorem and the fact that we were originally normal to begin with. So remember, if we wanted to write this in shorthand, we would say that we're using a normal distribution model with a mean of 266 with a standard deviation of 2.065. Whoa, that's an ugly 5. Let me try to fix it. There we go. 5.9. So that would be the model we are using here. It's a model with the mean and the standard deviation, okay? Let's go ahead and look at the last part of this question. What's the probability that the mean duration of these patients' pregnancies will be less than 260 days? Now, the reason I know this is a sampling distribution question and not like our first two is because it says, what's the probability that the mean duration of these patients? So we're looking at the mean of a sample of 60 patients. So we are dealing with a sampling distribution. It's not like up here where it says what percentage of the pregnancies. So we're looking directly at individual pregnancies. In this case, it's saying what's the mean duration of these patients' pregnancies. So we're looking at these 60 pregnant women. So this is a sampling distribution, which means in our calculator, we will be using these numbers, all right? So still though, less than 260 is what we're looking at, less than 260. So we want to go to menu 5, 5. It's going to be our normal CDF. And we said less than 260. So we can leave that the same, all right? And we want to do less than 260. So the highest we will go is that 260. Now, down here, we are still dealing with the 266 as our mean. Remember, that was our mean either way, so we still get to use that. And our standard deviation is going to be this 2.06559. So we want to put in 2.06559, and we should be able to hit OK, and this will be the final answer for that last bit, 0.001838. Okay, so again, it's saying what's the probability that the mean duration of these patients' pregnancies will be less than 260 days? Well, it's a very small chance. There is only a 0.2% chance that they would be less than 260. All right. So that was a longer question and a little bit more to handle. So I think we're going to call it a day with that being the last question. So remember, our next video is going to be covering some extended response questions that have to do with this chapter, all right? And then we'll start looking forward to doing maybe an extended response question or two on your own to turn in. So as always, I hope you guys found this to be a bit helpful. If you have any questions, you can always stop at my office hours. They are held almost every day from 2 to 3, so feel free to just log in there and ask me any questions that you may have. As usual, thanks for joining me today, and I hope you guys all stay fit, stay healthy, and have a wonderful day.